All right, welcome. Today, we're going to talk about something you've probably seen, but maybe never really thought about: the incredible evolution of the X-ray. We're going to dive into how we went from this really slow, chemical-based process to the crystal clear, crazy fast digital images that are just standard practice in medicine today. So, think about it. If you've ever had an X-ray recently, you're in and out in no time. But that speed, that's a pretty new thing. The answer to why it's so much better now all comes down to a massive shift from actual physical film to powerful digital detectors. It's a revolution that completely changed medical imaging. So let's start at the very beginning. Our story kicks off with the OG method, film screen technology. For decades, this was it. It was absolutely groundbreaking stuff. But as you're about to see, it was a super demanding and delicate process with some pretty serious drawbacks. You see, film was a really unforgiving medium. It had what's called a narrow dynamic range, which basically means if the exposure wasn't just right, the image was useless, either way too dark or completely washed out. There was no undo button, no sliders to adjust the brightness later. What you shot was literally what you got, and that often meant patients had to get zapped again and again just to get a usable picture. And the workflow? Oh, it was a whole thing. A technologist would expose the cassette, then have to physically walk it to a dedicated darkroom, unload the film in total darkness, run it through this whole series of chemical baths, wait for it to dry, and only then could a doctor finally put it up on a light box to see what was going on. The whole process was slow, it was clunky, and it involved some pretty nasty chemicals. Then, in the 1980s, the first big leap forward arrived. It's called Computed Radiography, or CR. You can think of this as the bridge technology. It was the beginning of the digital revolution, because it finally got rid of the film and the darkroom. Okay, so instead of film, CR uses this special plate. It's coated in something called a photostimulable phosphor, which is a fancy way of saying it's a material that can trap and hold on to X-ray energy. This plate goes inside a cassette that looks just like the old film ones, but its job is totally different. It captures and stores a hidden or latent digital image. And Dr. Muhammad Jafar, one of our sources for this, puts it perfectly with this analogy. The plate basically has a memory of the X-ray exposure, holding onto that pattern of energy until it's ready to be scanned. And the best part? It's reusable, like thousands of times. So the workflow got way better. No more chemicals, which was huge. But it kind of created a new bottleneck. The technologist still had to take the cassette out of the room, walk it over to a special reader, and pop it in. A laser would then scan the plate, which released all that stored energy as light, and that light was turned into the digital image on the screen. It took about 30 to 60 seconds. A massive improvement for sure, but still not quite instant. And that brings us to right now, the modern era, and the technology that was a true game changer: digital radiography, or DR. This is the tech that finally cut the cord, got rid of walking cassettes around, and delivered on that promise of truly instant imaging. With DR, the detector is either built right into the table or it's a portable wireless panel. It captures the X-ray and converts it into a digital signal on the spot. And the result? You get a preview of the image on the screen in just 3 to 5 seconds. That one change, it completely revolutionized the entire hospital workflow. Now, there are basically two main flavors of DR. You've got indirect conversion, which is kind of like a translator. It turns X-rays into light first, and then it turns that light into an electrical signal. Then you have direct conversion, which speaks the language. It converts X-rays straight into an electrical charge. It's just a one-step process, which makes it super efficient and capable of producing the absolute sharpest images possible. So we've gone from this slow manual process to a kind of clunky one to a totally instant one. But what does all this tech actually mean for you, the patient, and for the doctors who have to read these images? Well, let's talk about the payoff. This table really sums up the whole journey perfectly. You can see the workflow going from slow to moderate to fast. And look at the dynamic range. It jumps from 100 to 1 for film all the way to 10,000 to 1 for digital, which means way, way fewer errors. But the one I really want you to pay attention to is that row labeled DQE. That huge leap in efficiency is measured by something called DQE, or detective quantum efficiency. It basically tells us how good the detector is at using radiation to make an image. Film was only about 22% efficient. CR got a little better, but modern DR systems, they can be 60% efficient, sometimes even higher. So what does that actually mean for the patient? It means the detector is just so much better at its job. A higher DQE lets it capture a really high-quality, useful image with a lot less radiation. And this right here is the key to one of the biggest benefits of modern X-ray technology: patient safety. When you get right down to it, every single one of these technological steps leads directly to better care for you. Diagnosis is faster. There are fewer repeat scans because the tech can see the image right away. The images are sharper, which gives doctors more confidence. And most importantly, all of this is done with a lower radiation dose. But all that power comes with a bit of a warning. Because these digital systems are so good, they can sometimes produce a pretty decent-looking image even if the patient got a little too much radiation. It's a phenomenon called dose creep. And it's why experts like Dr. Jafar really stress how important it is for technologists to constantly monitor exposure levels to make sure the dose is always kept as low as reasonably achievable. And look, this digital revolution isn't some niche thing happening in a few places. We're talking about a complete takeover. Today, over 95% of hospitals have switched to fully digital systems. The benefits in speed, safety, and image quality are just so massive that the old ways have been almost entirely left in the past. So from what was basically a delicate art form that relied on darkrooms and chemistry to an instant, low-dose, high-definition science, the evolution of the X-ray detector is just a remarkable story of innovation. It really makes you wonder, with imaging tech this powerful and this efficient, what new frontiers we'll be able to see next?